This is an example of an unbranded server. So it looks just like a Dell server, but it does not have a brand on it. Now, that's actually quite a supply chain innovation. If you think about it, we have, if you think about an assembly line where servers are being made, we can order an unbranded server with a minimum order quantity of 1 unit. So you have an assembly line where we're manufacturing Dell-branded servers, but then we get an order for an unbranded server, and we can manufacture 1 unit of an unbranded server. And what happens is, when you start up that server, it starts up with a blank screen. It doesn't start up with a Dell logo on it. So it's not just as simple as taking the badge off the bezel. Also, the product information guide, all the documentation that gets dropped in the box is unbranded. Also, the packaging that it ships in is unbranded. It's a white box. The only place you might see that it's made by Dell is on the regulatory label, where we leverage the regulatory label of the standard Dell products. So that's an example of an unbranded product. But you could go a little further. You can then customize bezels. You can select one of 4 preset colors. You can change the badge. You can change the shape of the badge. You can change the logo on the badge. Or you can completely change the bezel. Or you could have something like the Google search appliance, which has a completely different faceplate. And when you get to something that complex, we have to pretty much recertify all the thermals and the cooling for all these products to make sure that they still comply with our specs. But when it ships out of the factory, it is actually perfectly compliant to all the Dell standard specs. And all of this ships directly out of the factory. We also have extended life products. So if you notice, the standard product, a standard server, let's say, lasts about 2 years. We have about 3 months of transition time to the next server or the next model. An OEM-ready server has got 3 months of additional life. That's okay. You know, we just assume that when we ship to an OEM customer, it's going to be in their integration facility for a couple of months. So the end user gets a whole 36 months of warranty. But we also have an extended life server, which has a transition time of an additional 12 months compared to a standard server. That means that for a customer that has extremely critical software needs, someone in the oil and gas industry, for example, who needs to test their software to make sure that there are no hiccups when they switch to the next platform. This is extremely useful for them. Or you have cases where someone actually quotes a product, but it takes 6 months for the customer to make a decision, and by the time the customer comes back and says, yes, I want to buy that thing, it's already end of life. You can avoid that by having an extended life platform. We control the components at the supply chain side. We have back-end agreements with Intel so that they will continue to support the processor, and all the other parts we can basically buy in and hold an inventory of. But it basically means that we can tell you when transitions are happening. We can tell you, if you plan to sell this for another 12 months, that's fine. Go ahead, quote this. Otherwise, I think it's time you start transitioning to the next platform, the follow-on platform. We also have Internet of Things gateways. This is something new we started, and we'll talk about that separately. But basically, these are hardened products. You would normally not see Dell make something like that on the far right corner, but it's basically a hardened computing device that is designed to be installed into a factory. We'll touch more about this at the second part of our presentation. This is an example of a carrier-grade platform. This is used by telcos worldwide. And basically, this is a hardened product that's got extremely high operating characteristics, can run for 24/7 at about 55 degrees C. It's got a filtered bezel, built with fire retardant material, things that are very specific to a particular industry. And similarly, we also have a military-grade product. This fits into the back of a tank, but it can really be used in any environment that requires hardened products. I'm going to ask you a quick test here, just to wake you up a little bit. What's an example? So who can name an OEM product that you've just seen in one of the previous slides, other than the military-grade product? Just a quick memory test here. Anyone? Sir? So very quick. Let's go back a little bit. So we have our unbranded, rebranded, extended life, gateways, telco-grade, and military-grade. So those are basically the rough categories of products we have. So this is our basic introduction to the OEM solutions. Let's talk a little bit about what our business looks like and how channel partners can come into the picture. Any channel partners here, distributors or system integrators? Not that many, so maybe we'll go over this pretty quickly. So basically, our business falls mainly into three verticals. The first three that you see, which is telco, healthcare, and industrial automation. So we have kind of vertical solutions for each of those categories. We talked about the telco-grade server. We talked about healthcare. The GE Healthcare example. We have extended life products. Many cases when we make something that goes into an MRI machine, it's part of the medical certification process. So every time you change hardware for a medical device, it has to go through the recertification process. You can see how much value an extended life platform would add to that, because it means that you have to certify it a third of the time less by using a platform that runs longer. Industrial automation is the same way. You need long transition times. They really like hardened products, as well as they like extended life products. There are other things we do, like retail, aerospace, security surveillance. One of the solutions you'll see in the booth downstairs is a CCTV type system. So that's some of the other solutions we're part of. Now, if you look at the channel ecosystem, you find that OEM customers kind of fall into this category. They have vertical focus, they have depth. They know the industry very well. They are offering specific solutions to a particular industry. But channel partners, on the other hand, tend to have solution expertise. So they are experts in making kiosks, embedded products. They are experts in making appliances. There are certain SIs that are experts in integrating compute with specialized equipment, like MRI machines. And then there are people who provide end-to-end solutions, IoT-type implementations. So that's where we see partnership happening with channel partners. You'll find that we have cases, in fact, even in the Philippines, where we work with channel partners who partner with IP, intellectual property providers, to build a differentiated solution to the end customer. Here's an example of what that kind of model would look like. It's best to explain this with an example. Google is actually a pretty good example of that. Google is a software company. Google does not want to be in the hardware business, so all the offerings they make are outsourced to other companies. So when most people know the Google search appliance because it kind of looks flashy, but there's actually another product they make called the Google Cache Server that's installed into telcos, and that basically acts as a cache for YouTube. And that's one of the reasons where whichever country you're in, when you access YouTube, YouTube seems to run really quickly because they've got a cache at the telco, at the local telco, that is basically caching content. And the way that the supply chain for that server works is that Google provides the software to a third party, and third party is a partner that acts as an integrator and has a global presence. So they buy servers from us, a very specific type of server with software built into it at the factory. We ship it to a partner. The partner integrates it with some more IP from Google, and they make some late-stage configuration, and they ship it directly to the customers of Google. And so that's kind of how the value is added at every stage of the partner ecosystem. And we have a case like that even in the Philippines. We're working with a value-added distributor in the Philippines to kind of enable that process here. So it's actually a pretty mature process within our team. I've got a question again for you. How does warranty and support work in such a model? Assume for a second that something goes wrong in the field. Your end user is not happy. Something happened to the hardware. Maybe the hard drive failed. When they pick up the phone, whom do they call? Do they call the OEM? In this case, let's say, do they call Google? Should they call the partner who's helping Google deploy the hardware? Or should they call Dell? What are your thoughts? You only have 3 choices, so say it again. The partner. Anybody else? That's a good answer, by the way. Dell. That's also a good answer. Or Google. That's also a good answer. It turns out it's a bit of a trick question. There is no right answer to this. But the way we've set it up is that any of these models are possible. And the interesting thing is that these are not mutually exclusive. So we have cases where our OEM partner or the OEM customer is the first line of defense. And they pick up the phone, they say, okay, they are diagnosed that it's not a software problem, it's a hardware problem. They call Dell at the back end, and we have a special support line for them. So the moment they call, you can see exactly what kind of hardware they deploy, what kind of solution they have, what kind of BIOS customization they need. All of that appears on the screen for our tech support person, and we can deploy a service representative directly to the end user site. But on the other hand, we have cases where an end user calls Dell directly and says, hey, I've got a problem. I think it's a hardware problem, a hard drive problem. And our tech support representative basically can diagnose that and send someone down to, within 4 hours, the next business day, and have that replaced as well. So both support models are possible, and they are, like I said, not mutually exclusive. So that's basically our quick introduction to OEM solutions and how OEM works through a partner. I've got the second portion of our presentation is on embedded computing and Internet of Things. This was supposed to be John Lockhart, who's our BDM for IoT and an embedded PC was supposed to present this, but he's got called away because somebody else fell sick. And so he's in another breakout session. So I'm going to walk you through the rest of this, this presentation as well. So to get started, let's just talk about this. Feel free to look at all these pictures on the screen. What is embedded computing? Where do you think computing is happening here? In a truck? In my mind, to me, embedded computing is critical machines doing critical things. You know, this is stuff that a human shouldn't be doing because it requires a lot of precision. But this is very precision computing that's happening in real time, and it's kind of critical to a control system. You may not know this, but actually many of you may know this. The anti-lock braking system of a truck has got a huge amount of embedded computing information or embedded computing going on. So when a truck driver presses a brake, there are 18 wheels that need to be coordinated, and the incline it's on, the amount of the speed of the vehicle, the turn that it's on, the banking, all of that is taken into account when it kind of stops the vehicle. Similarly, I mean, you have a robotic arm that is basically a PLC that is connected to a computer. So that's basically embedded computing going on. And so you've got plenty of examples where we have this happening everywhere. So the question is, what do you think are some of the characteristics of a device that is used to do embedded computing? Any takers? What do you think are some of the requirements in some of these environments? Ruggedized, maybe? Rugged systems? Maybe very high dust protection. Some of these devices have something called IP, ingress protection ratings. What else? Maybe no moving parts. Completely fanless, solid-state devices. There's basically they're completely ruggedized. So those are some of the characteristics. Again, so what is embedded computing? Critical machines doing critical work, right? So some facts about the embedded computing market. You find that it's very vertical focused. Most of the embedded computing that is happening is really happening in the industrial automation space today. Industrial automation and traffic and transportation. They tend to be similar in terms of the characteristics of some of the boxes that are put into those systems. Next big thing is healthcare. So that kind of works very well with, if you remember, our three biggest verticals were healthcare, telecom, and industrial automation. So that works very well for us because we kind of have subject matter expertise in those industries. The other thing you could probably take away from this chart is that this is a market that is actually growing at double-digit growth. Double-digit percentages. Does anyone know how fast the PC market is growing or shrinking? It's about -7%. So we're shrinking -7% year on year. But this market is actually growing. So this is actually something that Dell would like to be in because it's basically it's basically computing with specific requirements for industries. So what is really driving it? And I think there are many factors of it. But if I could point to three things, it would be cheap bandwidth, cheap sensors, and cheap storage. So the cost of sensors is going down very, very quickly. So 3 to 5 cents is what it costs to make sensors these days. It's easy to transmit data, so cheap bandwidth. And storage is getting cheaper and cheaper. So it's kind of a confluence, a number of factors that is kind of getting people to take a second look at collecting information that they were not able to collect before. The fourth thing I could point to is big data and analytics. If you remember, if you came from a manufacturing or a supply chain background, the way you maintain process control is to take a batch of things out of the assembly line and then test them to see that they were complying to standards. Now you have enough computing power where you can actually check every widget that's produced on the fly for compliance, and you can kick out the ones that are not compliant. So that's kind of some of the drivers of the Internet of Things. So this is kind of our view on Internet of Things. Basically we look at IoT as a confluence of internet technology and operational technology. So OT is something that we don't play in. That's the analog world. Sensors talking to, or sensors getting data from the real world, passing it to kind of hybrid computing devices. And that's where the white space in between is where our gateways and our embedded PCs fit in. Because they're basically crossover devices. They're able to get information from sensors. Now, of course, you still need an ADC on top of a sensor to be able to pass that data to a system. But once you have that, this can be transmitted to the back end, and then we can do analytics on it, store it, do predictive monitoring. So all of those things. Basically, the idea is you can gather data, analyze it, and take action. So another question: how does IoT relate to embedded computing? If you remember, what was embedded computing? We said that was critical machines doing critical work. But if you connect all these little pockets of critical machines into an ecosystem where all of them are talking to each other, that basically becomes the IoT ecosystem. No? And that's kind of what we're trying to enable here. So to put that diagrammatically, you may have sensors detecting analog information, and then they talk to edge gateways that are consolidating that information, or to embedded PCs. And then now that we have all this information in digital form, we're able to store it, compute it, do analytics on it, and then drive action out of it. So that's basically what IoT is about. And some of the characteristics you find, we talked about having hardened environments, flexible supply chain, etc. In the past, we basically provided, we've sold Optiplex to kiosk manufacturers like ATM manufacturers, which seems to work for some type of solutions. But we've seen the need for hardened solutions. We've had customers come back to us and say, we like your global support infrastructure. We would like to avail of that, but could you give us another product that is hardened and built for the particular industry that we serve? And you know, an Optiplex desktop isn't exactly the kind of product that fits that niche. So that's basically the reason that we came up with the IoT and the embedded PC roadmap. We can manufacture, we have an MOQ of 1 unit, you know, which is not what a standard embedded PC manufacturer would be able to do. You know, for most people who are familiar with the industry, you go to a vendor and you ask them for a specific you ask them for a specific design. They set up the line, the supply chain for it. They'll give you a lead time of about 12 weeks. They will ask you for a minimum order quantity, build that, and then they break the line and build something else on it. That's not how Dell works. Basically, we are able to keep these in production. We also are able to keep them in production for very long periods of time, you know, for 5 years with the same kind of pro support that most of our enterprise customers are used to. So that's basically what we're offering to customers. Rugged, flexible devices, supply chain, quality, security, and service. And why do you think our explanation of why Dell is good at this is because we've been doing this for other devices for a very long time. We've been making rugged laptops and rugged servers for a very long time. So we kind of use the same engineers who had the experience of doing that onto our gateway and embedded PC devices, and as a result, we've basically come up with that roadmap. So I'm going to leave. This is my last slide, but I'm going to leave you with a picture of some of our embedded products. These are all fanless products. The one on the extreme left is an i5 or i7 Intel processor. But when it was running at full speed and at maximum throttle, you can put your hand on it and it would still be cold because it's got very good heat conduction. So it's basically a fanless device, extremely ruggedized. It's got military spec, and they can be customized in multiple ways. Our IoT gateway, for example, has got an HSPA adapter built into it. It's got connectivity that you would not see in a normal computing device like CAN bus or RS-485, RS-232.